This webinar is being held to mark World Healthy Life Day. The aim is to raise awareness about ways in which a healthy life can help protect and reduce severity of heart disease and many other serious medical conditions. This event is being organised by Healthy Heart Charity, the Cardiovascular Research Trust, with the help of partners in the UK and around the world. We shall hear from two speakers, experts in ways in which the metabolic syndrome can be reversed as an important way to reduce and indeed reverse cardiovascular risk. First, we shall hear from Professor Michael Lean, Professor of Human Nutrition at the University of Glasgow, who will discuss reversing metabolic syndrome through dietary measures. And then we shall hear from Professor Franco Capuccio, Professor of Cardiovascular Medicine and Epidemiology at the University of Warwick and immediate past President of the British and Irish Hypertension Society, who will discuss links between abnormal sleep patterns and cardiometabolic risk. There will then be discussion with our panel members, including Professor Bernard Chung from the University of Hong Kong and Annie Cruz-Smith, a chartered physiotherapist in the UK, along with questions from our audience.
I'm a diabetes person, basically, but I've been working more in prevention over recent years, and I'm going to tell a story, and I've got slides to show that story, which go back to my sort of origins as a diabetologist. The first slide, the opening slide with the title, incidentally, is a painting by Frederick Banting, who was accredited with having discovered insulin in 1921. He's a much better painter, artist than he was a doctor. He was a rotten doctor, a very poor scientist. He happened to be in the right place and met a man from Aberdeen who helped him discover insulin. That's a long and complicated story. I have, next slide, how do we move on? Where do we start? My clinical upbringing with diabetes, amongst other things, has taught me a few things. And I've pulled out here some figures which I think are quite stark and should change most people's thinking about type 2 diabetes. These are the 10-year survival data for 3 common conditions. Breast cancer, most people would consider to be a serious diagnosis, 80% 10-year survival, which is poor for some, but pretty good for most. Non-Hodgkin's lymphoma, 60%. Type 2 diabetes, only 50%, and these are current data. Of course, they're all age-adjusted and such like, but it tells us that this is a disease as serious as many serious cancers, and we should take its treatment equally seriously. If we offer a treatment for a remission of a cancer, we should be considering the same approach to type 2 diabetes, not simply covering it up with drugs which lower the blood glucose. We know already, and we've known for many years, that weight gain is the far and away the most important causal factor for type 2 diabetes. You have to have a predisposition, a genetic predisposition. Not everybody will get type 2 diabetes, but whatever your genes, you will not get it if you don't gain weight. So with a body mass index of 22 or 23, you are very, very unlikely to get type 2 diabetes ever. And you are able to climb mountains because it's a pretty fit place to be. And the risks increase astronomically. These are relative risk figures compared with the body mass index 22 to 23. And they go up to relative risks of 50, 60, 70. These are figures which tell you it must be a causal relationship. It's not simply a common ancestor, it's a causal relationship. And we already know that quite modest weight loss can prevent the development of diabetes. So this again is telling us that the process of developing type 2 diabetes requires weight gain, and by losing a bit of weight, you can stop that process, at least delay it for a number of years. And these are 2 very large studies which produce the same result, that by losing roughly 8 kilograms, even if you don't keep the weight off long term, that will remove over half of the new cases, the incidence of diabetes over a 4-year period. So that type 2 diabetes is a nutritional disease which is triggered by weight gain in susceptible individuals, that we know. And I go back to a very old study which Donald Singer may remember from Aberdeen, published 1990. This is a trial where we looked at the life expectancy of people with type 2 diabetes, overweight people, BMI over 25, according to whether or not they lost weight in the first year after diagnosis. And I've plotted here the years of life lost compared to people who never had diabetes. That would be 0. People with type 2 diabetes at diagnosis, average age 64, lose 7 years of life. And that figure was true in 1990. And sadly, it's very similar now. The figures are around about 6 years life lost on average. And you can see that as people lost weight with the help of dietitians, so this is intentional weight loss, they lived longer. And if you follow this up to the end of where our data provided statistical power, you can see that 15, just beyond that, 15 kilograms weight loss took the life expectancy back to the same as people who never had type 2 diabetes. So the 15 kilograms weight loss seemed to be a figure which would remove the added risks of type 2 diabetes. It's an interesting statistical study, and of course it's retrospective. However, the surgeons have told us something rather similar. These are just data from a number of bariatric surgery studies. And if you just look at the blue columns here, these represent the remissions of diabetes. That is, people who started diabetic, no longer diabetic after 2 years. And each of these is a different study, 2 years follow-up after bariatric surgery. They're different operations with different surgeons under different conditions, 72%, 75%, 68%, 85%. So this is telling us that most cases of type 2 diabetes can be reversed by bariatric surgery. Now, physicians depend on randomized controlled trials, and they said, no, we don't believe any of these old studies until we do a randomized trial. John Dixon in Melbourne in Australia did exactly that and found precisely the same, 75% remissions after bariatric surgery at 2 years. These figures rang pretty loud and clear. And how much weight loss did they require to lose? Well, John Dixon's study said, you don't need to lose 30, 40 kilograms. All you need to lose is somewhere between 10 and 15 kilograms to remove the diabetes. So we asked the question, can we do this by diet alone? And after a number of years, I finally got the funding from Diabetes UK to do this study, which is called DIRECT. This was a study conducted entirely in primary care in people with overweight, BMI over 27, and type 2 diabetes. And the study, they had a mean age of 54, hemoglobin A1C, a baseline was 55 millimoles per mole on treatment, and body mass index 35. So this study was conducted entirely by the practice nurse or dietitian, if there was one available, trained by our team. On day one, we said to our patients, we want you to stop all your anti-diabetes medications, all of them. And the reason for that is, we don't want hypoglycemia in the study, and if they lose weight, hypoglycemia could result. Secondly, we were aware that many of our patients didn't like taking medication and would find this a big incentive to adhere to the program. We asked them to stop all their antihypertensive medications, all of them, and diuretics on day one, because we know that with a rapid weight loss and a restricted diet, postural hypotension is a big clinical problem, and we didn't want our patients collapsing, banging their heads, etc., with postural hypotension. And we also know they don't like taking medication, so they prefer to do this. And we also had a protocol to reintroduce the drugs if needed. They then went on to 3 months, 12 weeks of what we call total diet replacement. So this is a formula diet with all the nutrients, micronutrients, to be nutritionally safe, with the aim, and it's 830 calories a day, with the aim that they would lose 15 kilograms in that time if they adhered to the program. Then there was food reintroduction with coaching to learn how to then introduce new styles of eating, not the previous eating which caused their weight gain and their diabetes, but a new style of eating, which was much more to do with following traditional food approaches, using natural foods and whole grain foods and such like, which led on to then full-time weight loss maintenance. We followed them up in a randomized trial for 2 years, but the study continues for 5 years of observations. We designed the study with the knowledge that on average, patients were unlikely to get remissions unless we do something. We estimated that perhaps 5% would have remissions at 1 year, and so the study was powered to be at 12 months. We thought the control group might have 5% remission rate, and the target group, the intervention group, we aimed to achieve 22% remissions. Why 22%? Firstly, because our public health doctors said 20% remissions would be a major step. We'd have to take this into account for policy. Secondly, the American Look Ahead study managed to get 11% remissions, and we said in Scotland we can do twice as well as any Americans. So we aim for 22%. The results are shown here. The control group, sure enough, 4% remissions. These were people who heard about the intervention and went down the road and got onto this program or something similar. The intervention group, amazingly, 46% of all of them, and that was an intention to treat number, so we assumed that anybody who dropped out had failed to make a remission. At 1 year, 46%, at 2 years, 36%, so still way above what we aim to achieve at 12 months. And these figures have changed the way diabetes is being managed across the UK and indeed internationally. If we look then at this is a little more detailed, to see how much weight loss is actually necessary, and these figures in blue is at 1 year and in yellow is at 2 years. And you can see that the conventional teaching around 5 kilograms weight loss has no effects at all compared, or nothing different from placebo. There are quite good remissions with 5 to 10% or 10 kilograms weight loss. These individuals are about 100 kilograms, so kilograms lost or percentage weight loss is the same thing. But up at the top end here, with 15 kilograms weight loss, we had 86% remissions at 1 year and 70% at 2 years. That's of all participants, so it's including the control group, some of whom lost weight for reasons, as we discovered later, other than because it was non-intentional weight loss. So some of these were not actually well people. If I then just show you the on average, 10 kilograms weight loss at 2 years, almost 2/3 were in remission. If I show you then the intervention group alone, smaller numbers, the pattern is very, very similar. But here you can see with 15 kilograms weight loss, 86%, that's the same figure I showed before, in remission at 1 year, 82% at 2 years. So these remissions in the intervention group, the remission of diabetes is being very well sustained, both with 15 kilograms and pretty well with 10 kilograms, 10 to 15 kilograms weight loss. These figures are very impressive, and it tells us that most cases of type 2 diabetes are going to be reversible if patients are able to lose a substantial amount of weight. I know you're interested in blood pressure, and some of our doctors were reluctant to stop the antihypertensive drugs and diuretics. We persisted, and they did. In the white line here are the patients, this is the blood pressure throughout the early phase of the study, to see what happened when we stopped the medications over the first few weeks. In the patients who had no medications for blood pressure, they had no history of hypertension. The white line here shows what happened. So their weights, their blood pressures fell by over 10 millimeters of mercury and settled out at around about that figure throughout the length of the trial. In the other lines show the patients who discontinued antihypertensive drugs, and in the yellow line is the most extreme, those who had 2 or more antihypertensive drugs. And you can see that none of them had a rise in blood pressure acutely during the time when they were losing weight. So it was entirely safe to stop all the medications, provided the patients are losing weight. And as I say, some of them had to then reintroduce the medication in order to control the blood pressure at a later stage, and we had a simple protocol to do that. But the net result of all these groups is that they ended up somewhere near 10 millimeters of mercury below their baseline blood pressure. So weight loss is a very effective treatment for hypertension. I won't tell you all the other results, we can discuss them, but overall at 2 years, and this is the sort of summary data, the intervention group had a lower weight by on average 8 kilograms. They had lower hemoglobin A1C with fewer people on medication, lower blood pressures with fewer on medication. They had a reduced Q risk. Their Q risk was halved by the intervention. And critically, their medical care costs, and we collected all medical care costs, everything that every time they saw a doctor or a nurse or a dietitian or physiotherapist, went to hospital, admissions, and all their drugs were substantially lower in the intervention group than in the control group. And they had a better quality of life, which is nice. I won't tell you in all the details about this, but there was also a complicated set of studies done by my colleague Roy Taylor in Newcastle, whom we were joint PIs on this trial, which showed that as the trial progressed in the intervention group who had a remission, there in the blue columns here, they had a big fall in their liver fat, a big fall in the VLDL export from the liver, and a big fall in their pancreas fat. In the other groups, which are those who did not get remissions, or those who relapsed, who had a remission at 1 year and then returned to diabetes at 2 years, these changes didn't happen. And they combined to produce a restoration, quite rapid restoration of the first phase insulin response from the pancreas. So at baseline, these patients with type 2 diabetes have an absent first phase insulin response. It was restored within 4 months. And their total insulin secretion capacity went back to normal after about a year. So slower restoration, but went back to normal. So this study has now told us some new things about type 2 diabetes. We look at it like this: populations are gaining weight. All of our populations are gaining weight. For many people, for the majority, 60% of people who do not have these genes for metabolic syndrome, gaining weight with age, in most cases, is not terribly serious from the cardiovascular point of view. Some will develop macrovascular disease, which can be attributed, and it's a relatively small risk in people who do not have metabolic syndrome. For the 40%, or roughly 40% of people who have the predisposition to metabolic syndrome, they have the genetic predisposition, weight gain for them will reveal type 2 diabetes, hypertension, dyslipidemia, and a number of associated features. And they are much more likely to develop macrovascular disease. They will also, if they get type 2 diabetes, develop microvascular disease. So these people are at high risk from weight gain. They are the highest risk group. And the exciting thing about the DIRECT trial is that we've shown that this process can be reversed. And this has really changed our way of thinking. We have to identify, we wish we could identify people much earlier in life who have the metabolic syndrome. Perhaps their slightly lower first phase insulin response is one feature of this. But it would be good to be able to identify them and focus them for preventing weight gain. Worldwide, there are several trials now. This is a meta-analysis or a systematic review, which is not yet published. We're working on it. There are several studies which have looked at remissions of type 2 diabetes. The Diadem-1 trial in Qatar is the most recent. They achieved a 61% remission rate at 1 year. And I'm showing just here the 1 year data. Compared to usual care, 12%. Both of those are higher than we've seen because they were treated within 2 years of diagnosis, so really quite quickly after diagnosis, whereas the DIRECT trial I've just shown you was within 6 years of diagnosis. And the longer you go not giving proper treatment for type 2 diabetes, the harder it is to reverse it. The Virta Health trial used a low-carb diet, which is rather unlike what we did. The low-carb trial achieved some weight loss, which is good, but only 26% remission. So not such a striking remission rate with the low carb diet. And I mentioned earlier the Look Ahead trial in the United States, which used meal replacements, achieved only 11% remission rate. But all these studies are producing important reductions in diabetes if you multiply them up across the population. So what we've learned in the summary for you is that, firstly, we must treat type 2 diabetes much more seriously. We should be treating it at least as seriously as breast cancer or a lymphoma. And we should offer a treatment which is to be taken as seriously as chemotherapy. If we had chemotherapy for type 2 diabetes, I think 100% of our patients would take it every day. They wouldn't say, oh no, we'll come off the diet or off the treatment for a weekend or for a holiday. We would treat it very seriously. So type 2 diabetes should be considered in the same bracket as a cancer. We now know what we can do to reverse it, and it means achieving a 15 kilograms weight loss. Probably doesn't matter how you achieve that, but we've used one approach which achieved it for 46% of our patients. We can do better, but that's a good start. And we think that in Asian people, it's likely that a lesser amount, perhaps 10 kilograms weight loss, will be sufficient to reverse most of their diabetes. In the future, there are many different ways in which we must learn how better to get more remissions and to sustain them for a longer period. There are lots of diet strategies out there. None of them is magic, but some of them may suit some patients better than others. So 5-2 diets or time-restricted eating, for example. There are new agents for weight loss and for maintaining weight loss, but no drugs have been licensed to maintain weight loss. And our great need here is to maintain the weight loss. We're quite good at achieving weight loss. And then we have studies now looking at food supplements, which might be able to increase the amount of GLP-1 secreted by the colon when food supplements reach there, and that will suppress appetite innately. I need to thank everybody involved in this trial. and this is everybody, but I'm going to focus particularly on Diabetes UK. This study was conducted entirely with charity funding, no government funding, no commercial funding, apart from donating the diet products. And we have to thank people who gave money to help us do research into diabetes. It's a huge thing. And I'll finish there, except to say, if you want to hear about it, we have food-based approaches, which will do essentially the same thing. This is one which we designed in Nepal using dal bhat, very conventional, traditional foods, but in the right amounts, and a very acceptable way to get the same sort of 850 calorie diet with the weight losses and to achieve remissions. And we've done the same thing in Scotland using basically porridge and lentil soup, the two favorite foods in Scotland. On that happy note, I'm going to say thank you very much indeed to all of you.
Thank you very much indeed, Mike, for an excellent introduction to the importance of the metabolic syndrome and how it might be reversed by dietary means. We are now going to turn to another very important aspect of our lives, that's to say, sleep. I am delighted to welcome as our second speaker Professor Franco Cappuccio. Franco is Professor of Cardiovascular Medicine and Epidemiology at the University of Warwick. He's also the immediate past president of the British and Irish Hypertension Society.
Thank you. Thanks very much, Donald. Thank you for connecting with us. I've been asked to just touch upon different aspects of healthy living in relation also to cardiometabolic disease. And I'm too going to tell you a story that started when I moved the institution from London to Warwick, and I was asked, amongst other things, as an epidemiologist, to develop a program around sleep medicine. And I thought hard, what should I do about sleep medicine? I didn't know much about it, but given I'm an epidemiologist, a cardiovascular epidemiologist, I decided to look at the epidemiology of sleep in relation to cardiometabolic diseases and see what comes out with it. Now, I need to give you a few slides of introduction. Right. Just remove that, fine. Okay. Now, first of all, let me get a bit of history. In 2017, these three scientists called Hall, Rosbach, and Young, in different labs, collectively were awarded a Nobel Prize in Physiology and Medicine. And the statement is for their discoveries of the molecular mechanisms controlling the circadian rhythm. And this was the first time they were bringing to the fore this new dimension of science, which is the study of human sleep. Human sleep has been always a Cinderella area of research for quite a long time. And the Nobel Prize was just rubber stamping what was the exponential speed of development of the science of circadian rhythm and of sleep medicine, as we found out as we start studying it. Now, right. So I need to introduce to you a bit of the sleep physiology first. Now, we have a body clock. The body clock, or our circadian pacemaker, is a bit like the heart pacemaker. It's made of a small number of highly specialized cells, which are situated at the center of our brain in the hypothalamus, in an area called suprachiasmatic nucleus. You can see on the left-hand side panel here in the section. It controls the timing of most of our 24-hour behavioral and physiological rhythms, which would include not only the sleep-wake cycles, but also alertness and performance rhythms, hormone production, temperature regulations, and metabolism. Now, the internal biological clock, which is genetically determined, however, is not set in every individual to exactly 24 hours. It varies, so it can be either shorter or longer than 24 hours. And this variation determines the definition that we say of individual chronotypes. That's from lay people, is what we usually use almost every day, referring individuals as having a propensity to be a lark or an owl, a morning type versus an evening type. External cues, which are mainly determined by the cycle of light and darkness, as well as other external influences like, for instance, noise, external temperature, alarm clocks, will determine the body and the biological clock to reset to a 24-hour clock on a daily basis, because this is a requirement for social construct. It's not for biological needs, but for social construct. So this phenomenon of resetting every day, we refer to as entrainment. We might touch upon a bit later why this may be important. Okay. Over the history of sleep, the humans have adopted different patterns of sleep. We know that if we do not sleep, we eventually die. So this is a very fundamental function. It's not an idle state or a waste of time, a useless time lost. However, how much is the optimal requirement for individuals in terms of sleep? We do not really know. In westernized populations, so it's the modern world, on the left-hand side, you see a frequency distribution here of self-reported sleep duration per day, which followed a bell-shaped distribution, with most sleep duration being clustered around 6 to 8 hours per night, making an average of about 7 hours per night. And when we see on the right-hand side, these are American data, we find that also cluster around 7 to 9 hours per night with an average of 8. But be careful, because these are only weekend estimates rather than daily estimates. It makes a point here that in the Western world, we already use the catch-up time for sleep as a weekend catch-up time. Now, beyond this bell-shaped curve, although the majority is in the middle, we see these significant tails, which make about a quarter of the population. Some sleeping less than the average, and some sleeping more. And for convenience of discussion, we shall call it from now on short sleepers and long sleepers. Now, this slide presents an ecological data, an ecological study, when we have here average values on the y-axis of self-reported poor ill health, and on the x-axis, the average self-assessed duration of sleep per night in several groups of college students across the world. So these are average data of groups. And as you can see, the majority of the duration of hours cluster around 7 to 8 hours. And the average baseline self-reported is about 10 to 15% of poor health. However, there is a threshold effect below which, in terms of duration of hours, where the self-reported ill health tend to go up. So this suggests that there is an association, there might be an association between duration of sleep and ill health. Now, when we started looking at this from cardiovascular epidemiologists, and I link up now to Mike, the one thing we knew for sure that there'd been an epidemic of rising obesity in the world, and this is American data, started from 1910 to 2005. And there was an observation of a very steady rise in average body mass index, which matched an average increase in the prevalence as well as the incidence or the speed of obesity. But at the same time, the same period of time, we observed independently that the average self-reported duration of sleep had declined quite rapidly, so that in this period of time, in 90 years, the Americans have lost on average more than 2 hours of sleep. Is that an association here? Is a link between these, the growing obesity epidemic and the decline in sleeping time? So obviously, we can't give an answer to that with that set of data without exploring more detail the question. So we set out a program of research at the time, and the hypothesis was focusing on whether the question sleep deprivation through a variety of physiological mechanisms could lead to an increase in risk factors and outcome of cardiometabolic diseases. And then we set out to try and test this hypothesis a different way. And I'll give you some examples of what we did. Now, this slide reports the results of the first systematic review and meta-analysis that we carried out of cross-sectional population studies in which both sleep duration, which is mostly self-reported, and prevalence of obesity had been measured in large studies in populations of either children and adolescents in the panel on the left or adults in the panel on the right. And the graphs used are known as forest plots. And I need to spend probably 1 or 2 minutes to help you understand this because I used a few of these in following slides. They report for each study that we analyze, that we look at, we summarize, the average outcome measure. In this particular case, are odds ratios. And the corresponding 95% confidence intervals of the association between the exposure, which in this case is sleep duration, and the outcome, which is obesity. The likelihood of being a short sleeper, if obese, is measured by the odds ratio. And the value greater than 1 indicates that the risk is increased. Now, if these 95% confidence intervals, these lines, horizontal lines, include the 1, which is this vertical line, that means the association is not significant. If it does not include it, the association is statistically significant, which in other words means it's unlikely to be due to chance. The final thing is the pooled analysis here. This is an analysis at the bottom, is a result of a meta-analysis taking account of all these different studies put together to give an estimate, allowing for differences between larger studies and smaller studies. So the sum up of these two are that both in children and adolescents, as well as in adults, those with obesity were more likely to be short sleepers. The association was strong, given the high odds ratio, and unlikely to be due to chance, as these intervals did not include 1. The meta-analysis also showed that there was some heterogeneity, but there was no publication bias. So could we say from these results with confidence that short sleeps may contribute to the development of obesity? That was the question we set up to answer. And the answer is clearly no. And I'll give you, if I can get to this slide, is no. I'll tell you why. Observational studies are unable to answer one fundamental question in relation to the sleep epidemiology. Is sleep deprivation a cause, a consequence, or a symptom? In the study of sleep deprivation and obesity in children and adults, the real possibility of a bidirectional model of biological plausibility requires researchers to dissect out the direction of this association, the direction of causality. In fact, from one side, if you look at the left side of this scheme, it is possible that sustained sleep deprivation through a chain of events, which I will depict a bit later in the experimental studies, will lead to an increase in energy intake and a reduction in energy expenditure, which in turn will be compatible with weight gain. On the other hand, if we start from the right-hand side, going backwards, overweight and obesity are conditions often causing sleep disorder breathing, sleep disturbances with fragmentation, and reduced sleeping time. Therefore, it is important that observational epidemiology only considers prospective studies in which the exposure of sleep deprivation precedes the development of weight gain or obesity, as well as other outcomes of interest. So in the next slide, I'll show you now this complicated forest plot. Don't look at the great details because this is the same as before. The only difference, and this is a meta-analysis of all studies carried out in children and adolescents, but this time these are only prospective studies. These are studies in which sleep duration was measured in non-obese children, and the children were followed up afterwards for a variety of years, and the weight gain, the rate of gain, or the increase in the incidence of obesity was logged as an incidence of obesity or overweight. As you can see, divided also by age groups, there was a very consistent association between sleep deprivation or short sleep at any given age and the chance of developing overweight or obesity with time, prospectively. The results were very strong, not including 1, and had no publication bias. What we can say then that these results are unlikely to be due to reverse causality and are compatible with a cause-effect relationship. Now, let's look at the biological plausibility of what we find. Obviously, we just observe, but we don't know what causes that. Now, we need to rely now on short-term intervention studies because obviously trials are the best tools to prove causality between an exposure and outcome. And we don't have at the moment any intervention where sleep duration is manipulated and long-term outcomes are measured. But we have short-term intervention studies, and I'll show you some very rapidly, all following with the same protocol, more or less. So the next few slides are very similar, and I've selected those in which glucometabolic mechanisms have been studied. All use randomized crossover trial designs in normal volunteers, studied in strictly controlled laboratory conditions and subjected to short-term sleep deprivation. In this study, for instance, 2 days of 4 hours per night sleep cause a reduction in leptin and an increase in ghrelin. These are hormones regulating hunger and satiety, with the net result in the particular of increasing hunger and appetite. When we look at this strip of graphs at the bottom, there is also a dose-dependent effect by which the shorter the sleep, the greater the reduction in leptin secretion. So we see a plausible physiological mechanism with a dose response, but also a reversible effect, given that these are randomized crossover studies. And when you revert it to long sleep, you revert the abnormality. When we look at this study here, using intravenous glucose tolerance test, and also looking at short duration as well as poor quality of sleep, so quantity and quality of sleep, on a variety of indices of other glucose tolerance or insulin sensitivity response, we show that all parameters studied, short-term sleep deprivation, as well as poor sleep quality, so fragmentation in this particular case, cause reversible glucose intolerance and insulin resistance. One study I particularly like is this one here, a very elegant study in which not only IV GTT was used in a number of volunteers who subjected themselves in a crossover fashion to 2 periods of 4 days of short or long sleep. But at the end of each period, they agreed to have a buttock biopsy where subcutaneous fat was taken out, and in vitro studies were carried out looking at some molecular mechanisms of insulin sensitivity at the central level. So this is the first molecular evidence to suggest that short sleep duration can interfere with would cause an impairment of the PAKT phosphorylation. This is an enzyme that is transduces, allows the insulin to internalize the glucose basically, and make the insulin act on the glucose metabolism. So a failure, an impairment of this would cause an insulin resistance, the insulin not being able to transduce the message from outside the cell to inside the cell. And this mechanism was reversible when the patients were going into other side of the study in a crossover fashion. So that is a very elegant, in vivo experiment. And finally, and this is just a selection of studies to show that the same short-term deprivation in similar crossover studies is able also to up and down regulate the genetic expressions of genes not only involved in circadian rhythms and sleep homeostasis, as you would expect, but also in a variety of genes involving oxidative stress and glucose metabolism. And that is a reversible effect when you when you prolong your sleep. So at this point in time, what we will set out with our hypothesis, we looked at the sleep deprivation causes an increase in appetite and reduces energy expenditure. And this for us is a plausible mechanism to justify the epidemiological evidence we see of the association prospectively with the incidence of obesity. We have seen from experiments in the short term that sleep deprivation causes insulin resistance and glucose tolerance, which is reversible when you extend your sleep. So it is obvious to think about it that this is the hallmark of diabetes. Our question was, can we detect a prospective association in populations long-term between chronic sleep deprivation and type 2 diabetes? And that's what we did, looking at all the meta-analysis, the studies we could find prospectively, not only looking at sleep duration, which is quantity of sleep, but also quality of sleep. So difficulty in initiating sleep, difficulty in maintaining sleep. And we found that short sleep as well as poor sleep is in the long term associated with an increased incidence of type 2 diabetes, very strong and unlikely to be due to chance. Obviously, as a cardiovascular epidemiologist, we look at the hypertension as well. And this meta-analysis, apart from some studies we did originally, others have followed up, has accrued also to the evidence that short sleep is a significant contributing predictor of the incidence of hypertension. And in this particular case, we also have a clear evidence with a randomized trial that if we are able to extend our sleep for about an hour in this particular study over a 2 weeks period, we are able to reduce the blood pressure profile even in normotensive volunteers. Now, finally, so far, we have a quick summary of what the studies have shown. Prospectively, short or sleep deprivation in populations we see increases obesity, increases hypertension. We have evidence, we've done a meta-analysis that has a slight increase in total cholesterol and total cholesterol to HDL ratio, and increases diabetes. Now, the clear question, does increase the outcome of interest? Well, I summarize now other meta-analysis without boring you with the plots that increase the risk of coronary heart disease, increases the risk of stroke, and also increases the risk of early mortality. And this creates the local mayhem when we publish the study, because that means that the life expectancy is reduced in short sleepers. So we drew up eventually this particular graph. And this scheme summarizes the wealth of evidence now accumulated by us and others in the last 20 years, extending the concept that sleep disturbances are not only a problem for the brain and confined to the nervous system. Sleep disturbances involve almost every system and organ of the body, with far-reaching consequences in the short and longer term. So I want to leave you with a summary, summarizing so far that the association between short duration of sleep, which could be considered as a new behavioral factor or a behavioral risk factor for cardiometabolic disease, may reflect the causality, because the effects are very strong. They're very large relative risk. They are consistent. They are confirmed in different populations for several endpoints. They show a temporal sequence, so short sleep precedes the development of these conditions, both risk factors and outcomes. And there is a dose response curve, although this is to be defined as a threshold effect and not a linear effect. There is biological plausibility, and I've only given a hint of what all the different studies on potential mechanisms involved, from genetic, molecular, cellular, and physiological. And more importantly, at least in short term and in small controlled trials, there is a reversibility of the effect. If you prolong your sleep, you tend to restore, at least in the short term, the cardiometabolic derangements that you find. And I want just to finish by acknowledging the funding across this program, which has taken about 15 years, not only run by us, but benefiting from a very large network of collaborators across the world. Thank you.
Professor Cappuccio, Franco, thank you very much indeed. Franco, thank you very much indeed. We shall now move on to questions by our expert discussion panel, as well as from our online audience.
Thank you. Really interesting topics, and definitely things that I'm really interested in alongside physiotherapy practice. Is a lot of our clientele do come to us with comorbidities, and particularly type 2 diabetes. And a lot of what we're doing is trying to educate them, and we're lucky enough to have an amount of time that we can spend with that patient, particularly some follow-up. But a question to you, Professor Lean, about your direct study. And you didn't mention in too much detail about activity, but was there an element of activity, and you know, what did you include in your study with regards to that?
Yes, we thought very hard and long about this. We had input from a chap called Mike Tranell in Newcastle, who I think you probably knew, who is a physical activity authority, professor of physical activity. Started his life as a professional boxer, to make life more complicated. In direct, we used existing evidence which says that if you try to ask people to go on a really pretty strict intensive diet program and do physical activity, then you effectively dilute your dietary intervention because they're distracted by trying to do physical activity. People who are overweight, people with type 2 diabetes, simply cannot increase their physical activity. The great majority cannot increase their physical activity. They are already working as hard as they can. They have limited cardiovascular reserve in many cases, and it just is futile to ask them to increase physical activity. However, what we did was to ask them at baseline, while they're going on to the total diet replacement, they aim to lose 10, 15 kilograms, we ask them to maintain physical activity, not to stop it, not to reduce it. Because, as I'm sure you know, people who are losing weight very often, or it's almost inevitable, they will become less active. It's a way to, the body conserves energy as you're losing weight. Your body tries to become less active. And so we asked them, no, don't become less active, maintain physical activity. Once they had lost weight after 3 months, we then said to them, the best way to maintain your maintain your lower weight, the best way to do that on evidence is to use a relatively high carbohydrate diet. Doesn't suit everybody, but that is where the evidence is, and to be physically active, to approach the levels which were seen in the North American Weight Registry, which are really very high levels of activity. They're talking there about 15,000 steps a day, not 10,000. And those are the people who successfully maintain weight loss. So we said, increase it if you possibly can. We gave them all step counters, and we gave them the program which was Tranell and colleagues developed to try to maintain and increase physical activity. The end result was they didn't do any of those things. They may have tried to increase physical activity, but they didn't. So physical activity was sort of it didn't happen, although we did want them to try to become more active. It's really, I think the lesson here is that people with type 2 diabetes have gone a long way down the route of decompensation, and they really struggle to become much more physically active. Some can, most of them can't.
Thank you, Mike.
Well, I think we have two fascinating thoughts, really, from two, world authorities. One alternative to weight loss and the diet is stay on the same calories, or even increase the number of calories, as Mike said, but increase their activity. So I mean that's kind of opposite end of the spectrum approach, and certainly it's been shown to prevent diabetes, such as in the Dating study in China. But I can see, I mean, Mike's point about, if you want to demonstrate the effect of diet, you have to, kind of isolate it and not combine it with, a physical activity program as well. It goes without saying that if somebody can do both, I think it's going to be probably twice or even synergistic, even more than twice as effective.
So I have a question both for Franco and for Mike. Would you say something about feasibility?
One of the things we know about people with type 2 diabetes is that they tend to sleep less, and this goes along the same pattern. When people are losing weight, especially on a fairly strict weight reduction program, they sometimes don't sleep so well. And I think my reading of this is that this is a feature of stress. So limited sleep, or losing sleep, or sleeping less is a feature of overall stress. And we know that stress, whatever that is, mitigated by corticosteroids or by catecholamines, will upset metabolism and raise blood glucose. So I think this is a story which is very well tied together. At the same time as we started Direct, Diabetes UK conducted a survey amongst people with type 2 diabetes to find out what they wanted to do, what they thought we should be doing in research. And their number one priority was to say, we would like research which tries to get remissions of type 2 diabetes. This was not expected, but that was what people with diabetes said they wanted. So the answer is, how many do we have to approach? Well, there are very few people with type 2 diabetes or with a cancer who would say no to the offer of a remission. It really is almost inconceivable that you would say no. Having said that, there were, of course, people for the trial who, and this is quite a demanding trial, who had holidays or who had social commitments, and for one reason or another couldn't come in on the, to stick to the protocol. So they said no for that reason. But the majority of people approached were very keen to do it. There's another factor here which we learned when we did this trial. Initially, we were forbidden to contact people to invite them to do this, except by letters which were posted and delivered to their doors. And we discovered that most people don't read letters which are posted to their doors because they didn't reply. When we rang them up, we finally got permission to ring them up. They all said, oh yes, we want to do that. So I think it's a very popular thing to do. And in terms of feasibility, as you know, already in the UK, the National Health Service is now making a diabetes remission service available across the country. The feasibility limit is having space in a busy, primary care centre to bring people in and to take them through the program. That might be minimized by doing them in groups. We didn't use groups in this study. And it's also limited by the numbers of dietitians available, because nurses can deliver the program, but we found it was slightly more efficient to use dietitians who were already trained in nutrition. And so that's what the limitation was. The most expensive part of the study, and I didn't show all the health economics for this trial, was the formula diet. And so that is the one which financially would limit the uptake. The initial investment is you have to supply the formula diet. But having said that, the overall cost of the intervention broke even with the savings after about 5 years. So once you've set up the remission service, then the savings that you're making from less prescriptions of drugs, less intercurrent illnesses, and in fact, significantly fewer serious adverse events start to save money for the health service. So the break even is about 5 years.
Yeah, I think in terms of sleep, we're probably a step behind the obesity diabetes framework. Obviously, the societal pressures, you need to understand why people sleep less. That's the first thing. And this is the exposure of interest. I haven't shown data that shows very clearly that the reason why we sleep less than before, because you go to bed too late, and not because we wake up early. And that's the first thing to say, right? That is an international study. And then also there are different categories of age bands. From children to adolescents, there are different reasons. And in adults, there are different reasons when you start working, when you go to school. But basically for children, it's very clear that the increase in the use of mobile phone, video games, and everything has contributed to the extension of their bedtime. So that they eventually, when they start going to school, they have the alarm clock, so they sleep less, basically, very simple. Now, what do you do to do it? One of the barriers is that there's all societal issues here involved, and so this is a public health domain. In fact, we have fed back into Parliamentary Health Select Committee on Health in England and Wales, and they're now considering it as a public health issue. But the major problem, we don't have an intervention. If diet is complicated enough, and Mike knows very well, it's easy to say you change the habit of people having a different diet. It's easy to say than done. For sleep, how you extend sleep in people. We don't have a single tool validated so far to make people sleep an hour more. All the small trials that we have so far are for 2 weeks in a highly controlled environment when you pay people, normal volunteers, to do the studies. So that is the challenge now. There are several factors that have been identified. It's very little to do with personal choice. And that's similar to diet and industry, for instance, when you don't have a personal choice of what quality of food you put in the food you buy, first of all. Yeah, you have a choice of choosing, but if you're surrounded by an environment which is obesogenic or diabetogenic, and would be moving towards that, you have very little choice that will help you. So we are at the moment in an environment which is producing less sleep in general. Urbanization, 24/7 society has led to that. So it's a public health issue, and identifying items is quite difficult. Some people started with mothers and families in children, preschool children. We've been focusing on preschool children, for instance, where you have a better way of controlling their habits before they go to school, and you delegate most of the time to other people. And there are some mechanisms that can work in early adulthood. This effect starts at birth, basically. The effect of sleep epidemiologic starts at birth, a bit like the diet starts at birth and builds up the problems in the long term. So I can't give an answer how feasible. At the moment, it's not very feasible unless you put education one side and also public health. When you go to adults, the other problem is sleep, shift work. Shift work is one of the major causes of sleep disruptions. And finally, Mike was referring to when people were losing weight, they were sleeping less. We've been very much focusing on one side of the bidirectional effect. Does sleep deprivation causes problems in the long term? Obviously, sleep deprivation is a symptom of millions of things. Anything like from depression to anxiety to pain, you sleep less. You don't treat sleep, you treat the basic condition, and sleep goes back to normal.
I think that that's entirely right. And the directionality of the links with sleep is going to be always potentially bidirectional. And physical activity as a way of physiologically leading people to take more sleep seem to be entirely sensible.
Yes, the argument is true. And physiologically, if you are more active, you tend probably to sleep better if you have a time, you have no pressures outside, because there's always the time of the healthy living in industrial societies, in big conurbations, is to have exercise at 5 a.m. or at 11 p.m. when the gyms are open 24 hours a day. I wouldn't consider that a very healthy exercise if you squeeze out of your sleeping time. The question is, sleeping time cannot be traded off for other things. And that's the question. The issue that was raised in children, when they spend more time, they stay awake longer. Okay, so they sleep less because they stay awake longer. And the wish is that they can invest that time in a healthy exercise, in a healthy time, whereas in fact, it's proven that most of the extra time the kids are awake rather than sleeping are spent in sedentary activities and snacking more than others. So that's one of the main reasons socially for fueling obesity in children. So this is a problem. Can we direct, even if they won't sleep a bit less and be more active rather than sitting in front of a TV and snacking crisps? That's really is the issue.
A question now on the chat list from Tom Hampen. What about early tonsillar surgery in obese children? Is that something which has got any evidence that it's going to make a difference?
Not necessarily the tonsils. I mean, the question is of links more also to the adults, when lots of people say it, and the sleep apnea syndrome, and all there are conditions, there are clinical conditions in which sleep is disrupted. So we only looked at the public health side of it. We don't deny that people who have some pathological reasons for being sleep disrupted should be treated. And the classic is sleep apnea syndrome, also because there is a big connection with all the cardiometabolic abnormalities. There would be, in pediatric age, some conditions that might lead to sleep disordered breathing, and the large tonsils could be one. And if you prove that there is hypoxia or there is difficult breathing or even fragmentation of the sleep, that could improve. But this is not a public health issue. It will affect a little number. It will definitely not prevent the rise of obesity in children. That's my point, coming from a public health point of view. That will be beneficial clinically, of course.
Thank you, Franco. Finally, a question for all our panelists. What about the value of assessing sleep patterns when looking into cardiovascular risk in your patients?
I can tell you in direct, we measured sleep time using also recording dates and times, and also with the activity monitors to see how many hours people were actually at least lying in bed. And we couldn't find any associations between the sleep time and remission of diabetes.
From a clinical point of view, I suppose that is one thing that we perhaps should focus a little bit more on, is sleep hygiene and sleep quality. We do touch on it slightly, but I think, especially from today, highlights that the importance of that to do with everything else that goes into a healthy lifestyle. And if we are treating persistent pain, which is a massive part of our caseload, it's perhaps looking at that as part of the whole picture. And I think one thing to note that at the moment, because a lot more people are working from home, we're seeing a lot of people decreasing their activity because they don't have that journey to work. They don't have to walk around the office. They don't have to walk very far to the toilet. So I think what we'll see in the coming future, perhaps, is people that need to be reminded to increase their activity, perhaps stand for a little bit longer rather than sitting all day. So I think putting activity into the day is so important, and perhaps we took for granted when we do go to a workplace. So I think that's definitely something that we'll take forward.
We're actually in the middle of using artificial intelligence to look at the predictors of type 2 diabetes. We found, to my utter surprise, that sleep was one of the strongest predictors. Absolutely surprised me. Weight, of course, but I mean weight and waist circumference, but next to that is sleep. So actually, today we're actually tackling two of the most important predictors of diabetes. One kind of simple concept we haven't discussed so far is this concept of the vicious circle. Person which is gain weight, is sort of finds it more difficult to exercise and so on, and goes into a vicious circle. And actually, eating also makes you go into a vicious circle, because the more you eat, especially sugary foods and beverages, you're going to go hungry several hours later, and you want to eat and consume more calories. So I think I think part of our job is really to break that vicious circle, isn't it?
A brief final question for you, Mike, from Ananta. Her question is, do people in different weight categories benefit similarly from the weight reductions you're seeing? That's to say, the overweight, the obese, the morbidly obese.
Never a simple answer, of course, but the answer was that whatever your baseline weight or body mass index, you still need to lose the 10 or 15 kilograms. And that's sort of relatively good news for people who are enormously overweight. If you start at 150 kilos, you still only have to lose 10 or 15. If you start with a body mass index of 27 or even 26 and 20 and have true type 2 diabetes with a fatty liver, fatty pancreas, then you still have to lose that 10 or 15 kilograms. It's probably less for Asian people. But it seems that we have to remove the last fat which has been accumulated to take away that ectopic fat which is put into these organs. There's an interesting body of work coming from Cambridge which is looking at the genetic factors which lie behind this metabolic syndrome, which tell us that what we perhaps already know, and that is that most people can put on some fat, and they put it on around, under the skin, the cuddly bits, the bits you can get hold of, and that doesn't matter too much metabolically. But there's a limit, and that limit is partly genetic, and it may be also aggravated by stress, and perhaps sleep deprivation is one of these stress features, to put a limit to the amount of fat that you can put into those adipocytes. And one of the slides that Francesco showed was along these lines. You then start putting fat into the liver, the pancreas, and it damages these organs. You have to get rid of that last fat, and that's why it's 10 or 15 kilograms wherever you start.
Thank you very much, Mike, for those final points. I should like to close today's World Healthy Life Day webinar by thanking all our contributors, Professor Mike Lean, Professor Franco Capuccio, Professor Bernard Chung, and physiotherapist Ali Crew-Smith. I'd also like to thank our audience for all your comments. You'll be able to look at recordings of previous Healthy Life sessions by going to our website, worldhealthylife.org. You will also be able to find out more about future webinars looking into important ways in which it is possible to prevent or reduce the severity of heart disease and other serious medical conditions.